All right, can everybody hear me all right?
Yes, I can hear you.
Awesome. Thank you, Brooke and Morgan, for filling out the chat box. And thank you all for joining us tonight. I hope we cover some interesting topics and everybody learns at least one thing. I am going to tell you a little bit about myself and then we'll go ahead and dive right in. Can everybody see the livestock digestion PowerPoint?
Yes, it just says livestock digestion with UW extension on the bottom.
Perfect. Okay, sounds good. So my name is Tycee Mohler, and I am a 4-H educator in Park County. I work in primarily Cody and Powell, and I have a beef production degree. I focused on nutrition and reproduction in college. I love all things animal science, and so I'm really excited to teach you a little bit about livestock digestion tonight. So before we get too far into the PowerPoint, who can tell me a little bit about what they think livestock digestion is and why it's important to know about?
Proper care of the animal, as well as making sure they have the correct nutrition.
Definitely, yes. So start things off, we're going to define digestion. And digestion is the process by which large nutrients are broken down into smaller molecules that the animal then can utilize as nutrients. And without breaking it down a little bit, the animals don't get any good from it. Just like if a human was to eat grass, it's not going to do them much good because their bodies don't break the grass down. So we have a couple different types of stomachs, and we're going to talk about different digestion processes in both. So we have multi-compartmental as well as simple stomach. And within those, we have ruminants, pseudo-ruminants, monogastrics, avian, and hindgut fermenters. And so even though their ruminants and pseudo-ruminants both have multiple compartments to their stomach, they do have a few differences. Same with the monogastric, avian, and hindgut fermenters. But there are several parts of the digestive system that are the same throughout all different types of stomachs. And so we're going to start by going through those. And all digestion starts in the mouth, or for the avians, the beak, which is the same. And this is where the breakdown starts. The tongue is used for mixing food, swallowing, and for some animals, that's how they pull the nutrients into their mouth. Then we have the teeth, which starts the mechanical digestion, and it is used to break down the pieces into smaller particles before being swallowed. And we have two different types of digestion, and both happen in the mouth. We have physical and chemical. Physical breakdown is in the mouth is done with your teeth, whereas chemical breakdown is done by your saliva. The saliva gets in and breaks down, using enzymes, breaks down the molecules into smaller particles. It also moistens the food and acts as a lubricant so that it can go down the esophagus better. If y'all have any questions at any point in time, feel free to either ask in the chat, raise your hand, or unmute yourself and ask at any point in time. The next part is the esophagus, and this is a transport system from the mouth to the main stomach. And it is a muscular tube that will carry the food down. And all of these different digestive systems have a stomach, but this is where they differ, and we'll talk about that a little bit further down. But the stomach primarily uses chemicals called enzymes to break down the food before passing it on to the intestines. Next is the small intestine, and this is a sphincter muscle, which means that it squeezes in all directions. And all of the different digestive systems also have a small intestine. The small intestine can oftentimes be broken up into 3 different parts: the duodenum, the jejunum, and the ileum. The first segment uses enzymes that break down proteins, starches, and fats, while the jejunum and the ileum primarily absorb these nutrients that have been broken down. They absorb the nutrients using villi, which are finger-like projections that come up, and those projections have blood vessels in them. And so that multiplies the surface area so that the transfusion can happen more rapidly throughout the small intestines. And each of these little finger projections will absorb multiple nutrients. The large intestine is the next part, and while all of these systems do have a cecum, the size of the cecum varies, and that's going to be very distinct difference between monogastrics and hindgut fermenters. Monogastrics have a much smaller cecum, but this is where fibrous foods are broken down. And then there's the colon, and this is where waste is stored, but then this is also where the bulk of our liquids, such as water, are absorbed into our bodies for use. And so we can see these 3 parts in this picture a little bit more clearly. And then we have the rectum, which is the terminal end of the digestive system, and waste is secreted. So are there any questions about the general digestive system? No questions? All right, we're gonna get into monogastrics. And these are simple stomachs because they have one compartment. They usually use their upper and lower teeth, and they typically do not chew cud. And just a fun fact, horses can't vomit. Here are some different illustrations of the monogastric stomach. And so it's pretty simple and straightforward. It has the esophagus, stomach, small intestine, large intestine, and rectum. Next, we have our ruminant system, and this is a multi-compartmental stomach, and ruminants have 4 compartments, whereas pseudo-ruminants only have 3 compartments. You know, I honestly don't know the answer to that question. I'm going to have to research that and get back to you. If you want to send me your email, I'll be sure to send you the answer to that question. The question for those of you, if you haven't seen in the chat box, was why can't horses vomit? Awesome, thank you. I will be sure to email that to you. So the multiple compartments are made up of the rumen, reticulum, omasum, and abomasum. Ruminants are often referred to as cud chewers because they do chew their cud, and we'll learn a little bit about that in just a stomach. Yes, so that is one of my favorite fun facts about cattle or ruminants in general. The question is, for a calf, that does the milk go to a different stomach than standard hay when they are developed? And the answer is yes. They have an esophageal groove, which bypasses the rumen, omasum, or the rumen reticulum and omasum, and goes straight into the abomasum. And it is activated by a suckling motion. So suckling calves, the milk goes straight into the abomasum, which is their typical stomach. It's the same as a stomach in a simple stomach animal. And that's true for lambs as well. And that's why bottle calves typically grow a little bit faster than bucket calves, because when the calves drink out of a bucket, the suckling motion does not cause that esophageal groove to connect straight to the abomasum. So the first compartment is the rumen, and this serves as a storage vat. And there are several different types of, whoops, I went too far, of bacteria in the stomach that begin the process of breaking down the nutrients. There are different types of microbes that break down different types of food, which is why it's important to switch your ruminant animals over slowly from either hay to grains or vice versa, or even switching different types of grains. Because each of those bugs ferments the food as they're digesting it, which creates gases and can cause bloat. There are finger-like projections all throughout the rumen, and they're very similar to the villi in the small intestine, but they are called papilla, and they absorb nutrients through the rumen wall to provide energy. And so here's a picture of the rumen, the inside of a rumen, and it resembles carpet. And these papilla will change color, size, and shape depending on the primary food that the ruminant animal eats. The next piece is the reticulum, and there are more bacteria and microbes here that will also continue to break down the food. And more fermentation takes place here. And this is where the food is, where the chewing of cud comes from, because the food, if it's not small enough, when it comes into the reticulum, will be regurgitated and re-chewed before it goes back through the process again. And this is also where non-digestible material will accumulate, because those materials are typically too big to go into the omasum. And this is what causes hardware disease. And so the reticulum sometimes is referred to as the hardware stomach. It's also referred to as the honeycomb because of the shape of the lining of the stomach. You can see the little honeycombs all over the lining there where the papilla are. I just answered the question, why is it called the honeycomb or the hardware stomach? So this next picture shows a little bit about the hardware. So the reticulum is right next to the heart. And so when those pieces of wire or those nails are stuck in the reticulum, sometimes they can puncture the heart, which will cause the animal then to die. And so that's what hardware disease is. It's from different things accumulating in the reticulum. And here's a picture where you can see some wire in the reticulum, and then you can also see where a nail has come through and punctured the heart. we kind of talked about this a little bit earlier. This calls it the reticular groove. I learned it as the esophageal groove. It's the same thing, but it's where the milk bypasses the rumen, reticulum, and omasum. And there's a typo there. It goes directly to the abomasum. The omasum is often referred to as the mini piles because it has several different folds, which increases the surface area for absorption. And then it has more papillae, but the papillae here are more blunt. Sometimes it's referred to as mini piles or the Bible stomach because it looks like a book. Then we have the abomasum, and this is the true stomach. This is where most of the enzymes that the body produces break down food even further, whereas most of the other breakdown has happened mechanically or through bacteria and microbes. And the gastric juices are also here, which is your stomach acid. Some characteristics of ruminants: they typically do not have upper front teeth. Instead, they usually have a dental pad, and then they also chew their cud. And this is kind of a crazy little fact, but an average steer produces 50 liters of saliva per a day. That's a lot of saliva. Here are some pictures of a ruminant stomach. So we have our rumen, which is the largest compartment, and then it goes into the reticulum, back around the front to the omasum, and then down to the abomasum before going into the small intestine. Next, we have our avian digestive system, and it's a little bit different than any of the other digestive systems. Instead of going to a glandular stomach, the food goes into a crop where it is stored, and then it goes to the proventriculus, and then into the gizzard. The crop is what tells the bird it's hungry, so when the crop is emptied out of seeds, the bird will eat more. So just like in the others, it starts in the mouth. However, they don't typically chew their food because they have a beak. They do do some breakdown with a beak, but not as much as we do when we chew. Then it goes to the esophagus, then the crop, which is where the food is stored and soaked, then to the proventriculus, which is their true stomach, just like our stomach. It secretes enzymes and acid. And in birds, this is a little bit different. We have saliva that starts chemical breakdown before it gets to our stomach, but they don't have any physical breakdown done before it gets to this part. Then it goes into the gizzard, and this is a muscular organ. And oftentimes you'll see birds eat rocks, and this is where they end up, and they grind all the food up in their gizzard, and those rocks will eventually break down over time too. And then they also have a small intestine, ceca, and large intestine. But they have one outlet for urinary and solid waste, and that's called the cloaca. So we talked about 4 different types of digestion. Who can name one? Anybody?
Chemical.
That is a type. Very good. What's another one?
Mechanical.
Mechanical or physical. Very good. What are the different types of digestive systems?
You guys can put it in the type or in the chat box too if you don't want to talk.
Is it ruminant?
Ruminant is one of them. Very good. What are 3 others we talked about? I guess we've only talked about 2 others so far.
What about your dog? That's the clue. Who knows what the dog is?
A simple stomach or a monogastric. Very good. And then what is the last one we just talked about? With the crop and the gizzard. Avian, very good. So what's the 4th type? I mentioned it a little bit earlier at the very beginning. Any guesses?
Hindgut fermenters?
Yep, hindgut fermenters, very good. So these are animals that eat large amounts of roughage like a ruminant, but have a single compartment stomach like a monogastric. They have an enlarged cecum, which allows them to ferment large amounts of roughage to aid in digestion. And some examples of a hindgut fermenter are a horse or a rabbit, or one that kind of surprised me is an ostrich. So we have our ruminants, and then a pseudo-ruminant has a 3-chamber stomach, but very similar to a ruminant. Monogastric, hindgut fermenter, or avian. Oh, and on the pseudo-ruminants, those are your camelids. So camels, alpacas, llamas, anything in the camelid family. So we're going to go through a little, I guess you could call it a quiz to see if we can guess what type of digestive system they have based on what they eat. So what do cows eat?
Hay.
Hay, so lots of roughage. Some grass, yep. Mostly roughage with some concentrates. Concentrates would be your grains like corn, oats, barley. They have 4 compartments to their stomach, so they're a ruminant. But they eat mostly roughage, so they have to have something to break that down. What types of food do horses eat?
Hay.
Hay, lots of hay.
And grain.
And grain, some grasses.
Alfalfa.
Yep, sometimes. So they eat mostly roughage with some concentrates, just like ruminants. However, they have a different digestive system. And they have upper teeth, so that's one way we can tell a little bit about their digestive system too. They are going to be a hindgut fermenter. So they eat lots of roughage, but they don't have a ruminant stomach. What about sheep?
Hay.
Yep, hay. They also eat mostly roughages with some concentrates. How many stomachs do you think sheep have?
4.
Yep, they have 4. So what type of digestive system will they have?
Ruminant.
Ruminant, very good. What about this guy?
One.
One stomach, good. What does he eat?
Seeds.
Seeds, so mostly concentrates. What type of digestive system does this guy have? Some bugs, yep, definitely some bugs. What type of digestive system?
Avian.
Avian, very good. What is different about an avian digestive system from a monogastric? They have a gizzard, very good. Whoops, I went too far. What do rabbits eat?
Pellets.
Pellets. What are the pellets usually made out of? Grass, good. Alfalfa, yes. So they eat mostly roughages and they have one stomach. What type of digestive system do you think they have?
Hindgut fermenter.
They are a hindgut fermenter. They're a monogastric hindgut fermenter. What's the difference between a hindgut fermenter and a just a normal monogastric? What's special about a hindgut fermenter? It starts with the C, and it's part of the large intestine.
Cecum.
Cecum, very good. They have an enlarged cecum. What about goats? Yep, they are very similar to sheep. They eat
Hay.
lots. Yep, hay, mostly roughages. Yep, they are a ruminant. Very good. What about pigs? What do pigs eat? Do they eat grass or corn and soybeans?
Corn.
Very good. They eat mostly concentrates. They have one stomach. So what type of digestive system do they have?
Mono.
Oh, yep, they have a simple monogastric stomach. What about a turkey?
Seeds.
Yep, mostly concentrates. Seeds are concentrates. What type of digestive system do they have?
Avian.
Very good. All right, so the next part that we're going to talk a little bit about is enzymes. And these break down the food chemically. So in the mouth, we have saliva, which begins the breakdown of carbs. In the stomach, we have gastric juice, which has a lot of acid in it, which is produced by the stomach, or in a ruminant, the abomasum. And then pepsin, which begins the breakdown of proteins. In the small intestine, we have chyme, which is an acid, and it helps with breakdown all around. And then we have pancreatic juices, such as trypsin, which breaks down protein, pancreatic amylase, which changes starch to a sugar, and then bile, which is a green liquid or a yellowy liquid produced in the liver and stored in the gallbladder, but this is what helps break down fat. Do you guys have any questions? Any questions at all? What is one thing you learned tonight that you didn't know before? You can type it in the chat box, or you can say it aloud. Chickens do have an avian stomach.
Sheep have 4 stomachs.
Very good. Thanks for sharing. What else? Anybody else learn something fun?
Learned that there's such a thing as a hindgut fermenter.
A hindgut fermenter. Awesome. So Johne's is a disease that can cause a lot of issues, but basically it causes starvation. So then anything that essentially it causes the animal to starve to death. I don't remember exactly how it looks, so without having notes in front of me, I couldn't tell you exactly, but I'd be happy to email you some more information about Johne's if you'd like.
Tycee, I have the information about the horses not vomiting.
Oh, awesome.
So just a little bit of an explanation is that when, just so that you can understand what causes humans to vomit, is that what happens is that when humans vomit, like lots of this happens simultaneous and you don't know what happens, but you like draw in a breath. And then what happens is that when you draw in that breath, it collapses your vocal cords and then your larynx rises. And then what happens is that soft pellet then shifts and closes off the airway and opens up from the stomach, the path from the stomach. And then what happens is that the diaphragm contracts, which loses the pressure, and then that sphincter muscle that you talked about that connects the esophagus to the stomach, then what happens is the sphincter muscle opens up, and then the abdominal muscles start contracting and doing spasms, and then that's what causes the upward trend. And so basically it's humans vomit because that sphincter muscle isn't super strong. And so in horses, the reason why they can't is because they're where the stomach and the esophagus connect is that it's a little bit lower down. So what happens is that sphincter muscle is kind of at a different location than really what it is in humans, and that the sphincter muscle works really well in horses. So it's super strong. So what happens is it's a little bit lower, and then it's really, really strong. And then what happens is also, since it's lower in where it connects, is that the abdominal muscles put more pressure on it, so it doesn't have the ability to open up. So really what's happening on horses is the sphincter muscle is really doing a good job at keeping that blocked off so it doesn't open back up.
Awesome. Thanks for sharing. That's kind of neat to know. I'm assuming horses probably don't get heartburn either then.
Right. They said that sometimes horses will throw up, but if they do, usually it's from a choke and not from an acid problem like what we have. So it's really, if you see a horse throw up once in a while, it's because they probably have choked on something and then regurgitated it back up. So Tycee, I just have a couple things. I'm wondering if the kids would share what county they're from so that we could just kind of mark that down.
Weston County.
Weston, who said Weston?
We did. Morgan and Josiah Stroh.
Okay, perfect.
Albany County.
And who's from Albany?
Tell your name.
Jaden.
Don't talk to me. Talk to her.
Jaden and Cole Clevin.
Okay, perfect. And I see a Washakie County and a Uinta.
And a Natrona.
And a Natrona, perfect. Was carbon, is that what I heard? Perfect.
Awesome. So if you all would like a worksheet to practice using this by, you can put your email in the chat box or email me and I will send that to you. Otherwise, that's all I have for you guys tonight.
Tycee, I have one more thing. If you want to stop the recording, I just have a couple announcements for animal science.